Hi, my name is Oktay. Welcome to today's video about the Hubble Space Telescope and its wonderful images. In today's video there will be Andromeda Galaxy and the Green Comet. The telescope is named after Edwin Hubble, who was an American astronomer. He discovered the true nature of the Andromeda Galaxy, and his redshift measurements showed that we live in an expanding universe. The Hubble Space Telescope was launched in April 24th in 1990. This is a beautiful picture of the Andromeda Galaxy M31, that's our neighbor galaxy. It is also the name NGC 224. This picture was taken from the Negev desert in Israel. And you can see two of the satellite galaxies. This one is M32 and this one is M110. And we will see that two satellite galaxies are different from the large Magellanic Cloud and the small Magellanic Cloud of the Milky Way. This is another picture of the Andromeda Galaxy in a different spectrum. It's a UV picture, and you can see the advantage of different spectrum. This gives you the structure of parts that are not visible in the other spectrum. The Andromeda Galaxy has a diameter of 200,000 light years. It has a mass of 1 to 2 trillion solar masses and contains 1 trillion stars. So this galaxy is bigger than our Milky Way. This is a Chandra X-ray image of the center of the Andromeda Galaxy. And it contains a supermassive black hole, Andromeda P2, which has a mass of about 110 to 230 million solar masses. So this is another example of the bigger and more massive galaxy containing a bigger and more massive supermassive black hole compared to the Milky Way galaxy, which contains a supermassive black hole with just a mass of 4 million solar masses. And there is another brighter mass concentration, which is called P1, just 5 light years distance from P2. This is the Hubble image of the center, which led to the discovery of the double nucleus. The brighter structure is the structure P1. There's a cluster of several million stars at a speed of 1000 kilometers per second. And this bright structure could be a remnant of a smaller galaxy, which merged with this Andromeda Galaxy. This is an artist's concept of the core of the Andromeda Galaxy. You can see many old red stars and a group of young blue stars. This is a very interesting method to find out more about the halo of the Andromeda Galaxy. This is the Hubble Space Telescope, and it measured the brightness of quasars from distant galaxies. Quasars are quasi-stellar objects. And for example, this quasar, all these quasars are in the direction of the Andromeda Galaxy, but this quasar gives no signal. No signal, which means there is no halo. However, these two quasars gave a signal, which means the signal is weakened by the halo, which gives you an idea of the size of the halo. And these two quasars at the bottom again gave no signal. And with this method, it was clear that the halo of the Andromeda Galaxy has a diameter of about 2 million light years. The halo contains gas, plasma, and dark matter. This is a nice picture of the giant stellar streams of the Andromeda Galaxy. This is about 200,000 light years. So the streams, for example, this NW stream, they are much bigger than the galaxy. And these were predicted by computer models of mergers. These are products from mergers that are still going on. And these structures are what was predicted. For comparison, this is a picture of the stellar streams of the Milky Way. You can see again product of the mergers. This is the same as in the Andromeda Galaxy, but a bit smaller. And here are the two most known satellite galaxies of the Milky Way galaxy. That's the Large Magellanic Cloud and the Small Magellanic Cloud. And those two galaxies are connected by a bridge of stars and gas. This is a picture of Mayall II, NGC 224 G1. It is a globular cluster which is 130,000 light years away from Andromeda's core. There are 460 globular clusters in Andromeda Galaxy. And for comparison, in the Milky Way, there's around 150 clusters. And what is interesting is the diversity in the metallicity of the stars. There are different types of stars, which means this cluster could potentially be a core of a consumed dwarf galaxy. This is an artist's conception of the satellite galaxy Messier 32 of the Andromeda Galaxy. This is an elliptical dwarf galaxy, so it's very different from the Small Magellanic Cloud and the Large Magellanic Cloud of the Milky Way. It is at a distance of 2.6 million light years and has a diameter of 6,500 light years. This is the Hubble image of the inner region of the M32 dwarf galaxy. This contains a supermassive black hole, M32 star, with a mass of 1.5 to 5 million solar masses. For comparison, the Milky Way galaxy's supermassive black hole has 4 million solar masses, so it's about the comparable size. And what is interesting is that half of the stars are concentrated in a radius of just 330 light years. This is the other big satellite galaxy, Messier 100. It's an elliptical dwarf galaxy and a satellite galaxy of the Andromeda Galaxy. It's located at a distance of 2.7 million light years and has a diameter of 17,000 light years. This is how the night sky in 4 billion years will look like on Earth. The Andromeda Galaxy is moving towards us, and there will be a merger with the Milky Way Galaxy. The speed of the Andromeda Galaxy is 113 kilometers per second. The product of the merger will be an elliptical galaxy, and some people have given it a name, Comet. And this event will also cause a starburst because it is an event which compresses the gas and dust masses by gravitation, and that causes a starburst. By this time, Earth will be long inhabitable. And yeah, but still, it would be a spectacular view in the night sky. This is a comparison of the galaxies in the local group. At the right, that's the Andromeda Galaxy, which is number 1 in size. This is the Milky Way Galaxy. It's the second biggest galaxy. And the third biggest is the Triangulum Galaxy M33. The fourth biggest is the Large Magellanic Cloud. And the Small Magellanic Cloud is the fifth biggest. And another galaxy, NGC 3109, is it's the fifth biggest, and Small Magellanic Cloud is the sixth biggest. This is a picture of the location of the big galaxies in the local group of galaxies. This is the Milky Way Galaxy with all its satellite galaxies. This is the Andromeda with its satellite galaxies. And this is the Triangulum Galaxy with number 3 galaxy in size. And all these galaxies are gravitationally bound. This is not a contradiction to the theory of the expanding universe, because the expansion happens at a bigger scale. This is the Triangulum Galaxy Messier 33. Picture is of the Very Large Telescope. It has one difference to Andromeda and Milky Way Galaxy. It has a spiral galaxy, but no real bar. Or a very weak bar. It is located at a distance of 2.73 million light years, has a diameter of 61,100 light years. The Triangulum Galaxy contains 40 billion stars and has a mass of 50 billion solar masses. It has many H2 regions. H2 means ionized hydrogen, and has a high star formation rate. This is a beautiful image of the Triangulum Galaxy, which was taken from Hubble. This is a combined image from many pictures and has 665 million pixels. And you can see from the bright structure the high star formation rate. This is one region within the Triangulum Galaxy, NGC 604. It's a star formation region with a size of 1500 light years, and the red material is hydrogen gas with dust. This is the future of the Triangulum Galaxy. It is also on a collision course with our galaxy and with Andromeda Galaxy. And a few billion years after the start of the merger of the Andromeda Galaxy with the Milky Way Galaxy, the Triangulum Galaxy will join the merger. And the result is a big elliptical galaxy. And you can see in the Milky Way, this is the bulge of the Milky Way, this is the disk. And the sun is here, halfway to the edge of the disk, at about 26,000 light years from the center of the Milky Way. This is another nice galaxy, NGC 1433. It's a barred spiral galaxy and a Seifert galaxy because it has a bright nucleus. It is located at a distance of 46 million light years and has a diameter of 95,000 light years. It's about the same size as the Milky Way. And this galaxy was discovered in 1826 by James Dunlop. And this is a composite image of ALMA, Atacama Large Millimeter Array Telescope in Chile, and Hubble Space Telescope of the central region of NGC 1433. And there's a jet from a central supermassive black hole. But what is unusual is this jet is extending for only 150 light years, which is very unusual. Again, a picture of the Hubble Ultra Deep Field in 3D. You can see the distribution of the galaxies in space and a big empty space in between. And this is the Green Comet E/2022 E3 ZTF. Its origin is the Oort Cloud. It came as close as 42 million kilometers to Earth. This comet has a diameter of 1 kilometer. Its orbital period is 50,000 years. And the green glow comes from dicarbon and cyanogen. So this comet contains basic organic compounds, like for example the basic amino acid glycine. And the chemical reaction with the radiation, cosmic radiation, produces these two compounds, dicarbon and cyanogen, and this gives this color. This gives this comet its green color. This is a nice diagram. This axis is logarithmic. It shows you the location of the Oort cloud. It's in the outermost region of the solar system. These objects in the Oort cloud are still in the gravitational field of the sun. They are held by the sun. This is the location of the Voyager 2 spacecraft. It will take another 300 years for it to reach the Oort cloud, and another 30,000 years to get to the outer edge of the Oort cloud. And what is very interesting is the star Ross 248 will approach the Oort Cloud in 40,000 years. So the orbits of the stars are not as have less order than, for example, the orbits of the planets around the Sun. Each star has its own individual orbit. So the stars that are today close to the Earth, to the Sun, will eventually drift away, and other stars will come closer. And one of the stars is Ross 248, and other one is Gliese 710. That was today's video about the Hubble Space Telescope images featuring Andromeda, Triangulum, and the Green Comet. Thank you for watching. Have a nice day. Bye-bye.